All right, we're live,
Woo.
and we kind of have a sort of, not quite, but some of an unboxing going on because what did you get in the mail, Jen?
I got my own RC racer with the
Yeah.
Jetson Nano.
Aha. So it
hmm
came with the Nano and everything?
Yeah,
Is it all pre-assembled or is it in pieces? Do you know?
believe it should be in pieces, but we'll find out pretty soon.
That's better. I mean, it's fun. That's the fun part anyway, is getting to assemble all that, right?
Yeah,
I mean, that'd be too easy if it just came all pre-assembled and everything.
yeah,
Otherwise, they're
and
gonna
plus
come
it's easier
pre-trained.
for me to take measurements of each of the parts, right?
Yeah.
So once you take those measurements, you can then convert that when you're making the CAD models for them,
Yeah.
right?
Cool. I love it. Um, Also, we just got back from SIGGRAPH,
Oh yeah,
and it was cool.
was it cool?
It was really cool.
Was it cool? That was kind of like a. It was cool, kind of. It was really cool. There
It
were
was
some
really cool.
pretty amazing things that were there. I got to meet um, some of the people in the community, so I got to hang out with Edmar and meet some of you guys, and then
Yeah.
I got to hang out with some of the really amazing companies and ISVs out there that are also working with Omniverse and
Yeah.
just USD in general. Wow, the huge
Yeah. That
impact that it's
Alliance,
made.
what's it called? The Alliance for OpenUSD. Is that what it's called?
Yeah, yeah.
That's really cool. So we've got who all's in that? Who all is in that? Let me do a quick Google. It's AOUSD. Is that what it's
Us.
called? What's that?
Yeah,
Well, we're
us.
in it
We're in it.
clearly. Let's see the founders.
I believe it's Adobe is in
Here
there.
we go. Membership, mission. Who's already a member? General members, founding members. Here we go. Pixar, of course, seeing as they invented it.
Oh, yeah.
Adobe, Apple, Autodesk, and of course ourselves, NVIDIA. But then we've got a bunch of other members like Cesium, Epic, Foundry, Hexagon, IKEA, Side Effects, and Unity. And I'm sure there's other people joining. So I think it's awesome. So I think about it, and uh, like, wouldn't it be nice if HTML had started this way instead of having all the browser wars and stuff?
Well, yeah. But the internet back then was a very interesting place, I would say, right?
Well, it
Like
was
it was
Wild
just
West, right?
yeah, it was like so new and like nobody knew how big it was going to end up getting.
Yeah, it's so true. So yeah, that was awesome. The keynote was really cool. The NVIDIA keynote. There's the SIGGRAPH keynote was cool too. They actually had somebody from the IBM Watson lab who came and talked about their about fusion reactors. No, not fusion reactors. About quantum computers. Why did I say fusion reactors? Yeah, he talked about quantum computers, and you can hop on one of their quantum computers.
That's pretty cool.
Yeah, so cool. One second, I got a ping.
I was kind of hoping to show each individual part, but again, it's a box with an air box in it. That's completely taped everywhere around. You see that shininess?
Well,
That's
they weren't
all.
going to lose any parts. This is like the
Oof.
best. If you think about it, this is the best unboxing ever, right? Because it's like multiple unboxing.
Multiple unboxing. Well,
Boxing,
we also got bubble wrap, the best part, right?
There we go. Jen's got a fun evening planned tonight.
I certainly do.
Cool. Let's see. Yeah, honestly though, my favorite part was just meeting so many NVIDIANs, because
Yeah, it's
we
been
always,
a while.
well,
Right?
we work remotely. We all work a lot. So many of us work from home that I've worked here for a little over a year, and there are a lot of people I work with daily that I've never met in person. Like Edmar. I had never met Edmar before. Can you all believe that?
Yeah.
I guess Jen can believe it. Yeah.
Yeah.
All right. What? Let's see. Should we get to the JetRacer stuff?
Yeah, I'm kind of curious what your updates are. I want to hear more.
I haven't made a lot of progress since I was gone on vacation and then to SIGGRAPH. So I thought we just work together today. And let me just show you all this. Just a minute. Let's go to the JetRacer GitHub right here. And where is it? If we go to Docs, Tamiya, no. Somewhere. Actually, if we go to the homepage, he's got the tutorials. Here we go. Basic motion. We've done that, right? That's where you just move the wheels, move the throttle. We skipped the throttle, but we're not too worried about it. Okay, but then road following. Boom. We want to use this notebook, which already, let's see examples. Here we go. For road following, if we had the actual physical car that we were doing this on, we would connect to the car, and then we would open up this notebook that Chitoku's made in Jupyter Labs. And then he's built a trainer out of a Jupyter Notebook where you just place the car on the road in different spots and teach it kind of what it should be doing. And so you just you put it on the road and then you click on the screen where you think it should steer. So you just train it by hand this way, right? It's called supervised learning. And actually, I think Edmar might be rolling in.
Who, me? Did I hear someone call my name? It's like I dream of Genie.
How's it going?
Good. How are you guys doing?
Great.
I'm so sorry. I just speaking about your great stuff you're doing this live stream. I'm late because I was just meeting with this great influencer who's creating great content on YouTube, computer science background. His name is Israel. I'm going to post his link in the chat in a second. But he wants to dive into Isaac, and I said that Eric and Jen are interested in jumping into Isaac soon on their live streams too. So he might be watching right now. So Israel, if you're watching. These are the folks I was telling you about, and this is a stream that I thought you should watch. But yeah, no, we all just kind of came back from SIGGRAPH, and he was very excited to chat about everything he learned and wanted to know what was coming and when. So really cool. So I'm looking forward to that. But that's why I'm a few minutes late.
Well, sounds good. I hope he's watching.
So what, not to interrupt what you're discussing right this second, but just out of curiosity because we were talking on the side yesterday about potentially like doing some Isaac stuff. Related to that, I had a chat yesterday with another great community user, Matthew Schwartz from NJIT, who has this really awesome idea for doing like a BattleBots type of contest. He's like, you guys should do a BattleBots contest and have the community work on like BattleBots and using Isaac Sim and Omniverse and really leveraging all the great stuff. And I said, well, Eric's starting to tackle some of that stuff with Jen. So I think it's a great idea. I think that'd be so much fun. So anyway, so really cool stuff and really lines up with what you guys are focusing on in the stream.
Oh, thanks. Yeah, and I think I think absolutely people can do BattleBots. I think the core that we're working on are, the idea here is that if you have different drive types, so different robots move in different ways. Mm-hmm. I mean, a robot can have 2 wheels with a caster behind. It can have 4 wheels like a car. It can have tank treads. It can have legs.
Yeah.
I mean, there
a lot
are
of variables.
There's different ways that these cars can move. And what we're trying to demonstrate here is that if you pick one of those kind of locomotion types, motion types, then you can create a template for, like, we're making an Ackerman steering template. An Ackerman robot is a robot that steers like a car, right? It's got 4 wheels and the front wheels turn. That's an Ackerman robot. And it's called that because it's Ackerman steering is what you call that kind of, wheels that steer. And so we're developing this Ackerman robot. But if you have a different sized Ackerman robot, you can still follow right along.
You can scale it. Yeah.
You could use our templates. You could scale it. You could almost use what we're doing right out of the box. Just with
So
some
how do people
tweaks.
find these? How many templates are there right now available to people? Like, do we have a bunch now?
There's a different. So if you have the kind where it's got just 2 wheels
Mm-hmm.
with a caster in the front and the back, that's called a differential robot. Called that way because it's, I don't know why they call it a differential. I mean, differential is what goes between the wheels, but that's what you call one of those kinds of robots. And there's the JetBot. It's a standard. You can buy a JetBot, online, and there's also a JetBot template in IsaacSim.
Yeah.
I believe there's a quadruped robot in IsaacSim. There are a few templates in IsaacSim.
So the one you're creating now, it kind of is a little different from the existing templates they had.
Yeah. So the existing Ackerman template, they actually have a little JetRacer model in there, and the thing about it is it uses this off-the-shelf physics car template that was originally designed for video games, which you can do a lot of cool stuff with that, but it doesn't use the actual suspension geometry.
I see. That's super realistic. Yeah.
Yeah, and so we're wondering if we can make it more realistic by actually modeling the suspension.
Very cool.
And then the other reason we're doing that is so that if you have a non-Ackerman robot, if you just got some robot that you've dreamt up that's not any of the standard templates, then you should be able to follow along this and build anything, because you can build whatever you want with joints and friction and these core physics functions that we're using. So,
man, the more you talk about it, I think this would be a great kind of contest. See what people come up with.
Yeah, well, and I think it would be great to have. So that's like the motion template, right? That's how the robot moves. But I think it would be great to have like a grabber arm template and a lifter template. Think of all of these different.
Yeah, you can combine and mix and match.
We can combine. Yeah. And my kind of thinking is that if we can come up with a way as a community to make all the motion templates and then make all the other robot templates, the lidar scanner template, the arm grabbers template, the I don't know what, then, and how to train those, then we can, and for architecture lets us mix and match, then you guys can go out and build whatever robot you want.
Yeah, I love it.
And
I'm definitely, you've compelled me to start looking into robots myself. So I'm gonna find it. Maybe I'll talk to Papa Chuck and he could be my mentor, my community mentor on doing some kind of little robot. I want to do something that could really like mess with our animals here in the house. We've got chickens, we've got cats, we've got dogs, we've got a bunny, we've got a gerbil. So I want to add a robot to that mix.
Man, there's a little like out of the box quadruped you can get off of a website, but it's Arduino, dang it. So I would love it if someone would come up with like an open hardware Jetson quadruped, so you can have like a little doggy, like a little dog robot walking around.
That would be cool. It's exciting time though.
And if you have a 3D printer, that just makes it so much easier. You can literally make a business out of that. Easy.
You know who's got a 3D printer? Ashley.
Hey,
our manufacturer.
Comment from Zier, real quick. He says, "What's wrong with Arduino?" There's nothing wrong with Arduino. I just don't work for Arduino. I work for NVIDIA, and so we're doing stuff with Jetson, not with Arduino. and yeah, and
I mean, in theory, you could.
In theory,
right?
Yeah, no problem. If you all want to use Arduino, more power to you. Although I do think that the Arduinos can't handle, especially the Jetson Orin is really powerful. So I don't know if an Arduino could do quite as much as an Orin. But I actually don't know. I haven't looked into the Arduino specs, so I should be careful. I could be wrong. Who knows?
There's so many different Arduinos too, right? So like there's
Yeah, it's
more than
true.
just one. So if you're not familiar with it and you're just starting to get into it, it can be very overwhelming. Like for me, it was super overwhelming trying to figure out, because I'm trying to make a automatic watering system for my herbs, and it's just super hard to do, right?
Yeah.
So
Are you using AI for that? You can like have it look at the dirt and see if it needs water.
ooh, I think my audio died. Hold on.
No, I hear. Oh, we hear you. It's so cool to see Zia and the other community members here. Zia was part of a great conversation we had yesterday with Frank and Paul. Rafi was there on SIGGRAPH related announcements. We talked about Run USD, and Frank went over the Omniverse platform. So if anyone's watching this and you're interested in kind of some of the big stuff and where Omniverse is headed and what the latest features, yesterday's live stream is great. It's on the YouTube channel, and Frank did a really nice overview deck. You can follow along. By the way, in case, because I'm thinking about Zia right now, actually, in case anyone out there is looking to work for NVIDIA, we just posted a great job for 3D technical artist background for training. So we're looking for people to help teach. So I'll post a link in the chat in case any of your viewers are interested. But I would say it's an exciting time actually right now if you're interested in working for NVIDIA and you're very passionate about the work you do. Those are the people we look for, and the NVIDIA careers page is a great place to go.
Okay.
We've seen a lot of new roles open up, and Jen's back.
I can hear again.
Speaking
My headphones. So like I heard you were doing like this little thing. I'm assuming you were talking about sensors.
I don't think so.
No.
No.
We're talking about mice. No, I don't know what we're talking
No,
about.
I don't know. Sorry.
Who is it, Eric or me?
Playing the piano? Okay, I'll go with that. I assume it was something very sophisticated, and I'll probably hear about it later. But
There you go. Yeah, cool. There's a lot going on, and I think that I am just loving this. I'm loving getting into robotics. It's so fun. I'm not very good at it yet, but
I think that's what's great.
certainly enjoying it.
I think that's great. What's great about this stream and also Ashley's stream is that it's really fun to explore learning something with you at the same time. The three of you are just fantastic about showing the process and the thinking behind troubleshooting, working around different issues and diving into the documentation in real time. I think it's super inspiring. And we heard people from the community at SIGGRAPH, same thing. So I'm super excited you guys are doing this stuff.
Cool.
By the way, Jen, if anyone's curious and following up on a previous controversy on this live stream, I did deliver coffee to Jen last week.
yeah, but I wasn't the only one.
Yeah, well, I couldn't give coffee just to you. Everyone would be like,
yes, you could have. You didn't promise coffee to anybody else.
Pick favorites.
Okay, they need to get in line.
Oh gosh. Yeah, but did you give the coffee to Jen first? That's the important.
No,
hold on a second. That's not
Oh.
fair. So hold on a second. I was rooming with Vince Brisebois. He saw my bag when I opened it. I couldn't be like, don't look. I have to give it to you.
Yes, you could have.
You were the first person that saw it outside of my room. How's that?
There you go.
And actually, Jen, forget like we have never met, right? And we never had the first time we've seen each other at SIGGRAPH, right? So our first thing out of Jen's mouth is not like, "Oh my God, it's so great to meet you. It's been so good working together. Where's my coffee?" That was the first thing.
Priorities. I need my priorities first.
It's awesome.
Oh gosh.
Anyway,
But
it's great.
so I know Eric has shown his Jetson, and this one's mine.
Oh.
This is the
Ooh.
Nano.
Wait, we got it. How do I highlight your screen? Just a second.
You go to the
Solo layout.
Yeah.
Boom.
That's great.
Isn't that beautiful?
It is.
Nice.
So you just got it?
Yeah, well, I got it when I was in SIGGRAPH, but I had it delivered to my dad's house. So
Nice.
but so yeah, this one's the Nano, which I think you have the Orin.
I do, yeah.
Yeah. So if anybody's interested in what the Nano looks like, well, I guess
It looks the
in terms of a grande Starbucks mug,
there we go.
so medium. This is how big it is.
So the big question from Zia and others is probably the same. What was it cost?
You bought a whole kit, right? You bought a whole.
Yeah, I bought a whole kit, so it was included. If you're asking about the price of just a Jetson Nano, I can quickly look that up.
Like $150, right?
Yeah, I would somewhere between there. Yeah.
That's not too bad.
No, there's like the 4 gigabyte and the 8 gigabyte, and I don't know. The Orin was about $500, which is cool because it's actually more powerful than the previous. There's the Jetson NGX or AG. I have a hard time with the acronyms, but there's like the commercial Jetson that was $2,000, and the Orin is actually more powerful than that previous generation commercial one. So yeah, you're $500 for the AGX. There we go. Thank you, Zia. The Jetson AGX from that previous gen is it's like $2,000, and the Orin Nano is more powerful than the Jetson AGX. Now there is an Orin AGX, I believe, that's I mean, way even more powerful, but yeah.
Very cool.
I saw this video. Zia showed it to me. It's really cool. They have this robot at the on-site and the Santa Clara NVIDIA location. You can walk up and ask it to take you to a conference room, and it will like take you there.
Hold on a second. I just thought of something. I don't know why we've never done this before. Zia, you're here right now. Do you want to jump on the stream? I could send you the link. You can come on with us and chat.
Yeah.
If you, I know sometimes he's not available by webcam and mic, but Zia, if you're interested, let me know. I'll shoot you a link because I think it'd be cool to have you on here. If not now, another stream.
For sure.
No pressure.
One big question, just while we're talking about SIGGRAPH really quick, that came up because we talked about this yesterday, but for those who missed the live stream, a lot of people are asking about ChatUSD, when it's going to be available. It is very, very soon. We've been fooling around with a lot here, as we showed yesterday. It looks like a ultra powerful tool, and actually be really cool to see used on this live stream too, because you can ask questions and help with the code. And there's a play button in it, so you can actually it'll insert the code right into Omniverse for you from the from the prompt. Really, really cool. Okay, that's okay, Zia. Next time. One person I met with also at SIGGRAPH, I met with administrators from a makerspace at a library. I believe they're in the LA area, and they would like to. They were talking to us about how we think any of our tools.
Sorry, Edmar. Just important comment. I mean,
that's old news, man. That's old.
Wait. But what about my beard? I don't understand. Why is only Eric's beard the most magnificent? What about mine?
Sorry,
I've got some great eyebrows.
He does.
I think, but Eric, I've told him before in the stream, but I think Eric, one of the things I also love about watching the stream is that you have a very nurturing, calming voice. And I think it's very it's like in the ASMR territory a little bit. If you were to put this in a different time slot,
ASMR. I don't know what that means.
ASMR is basically, oh God, what should it stand for?
What's ASMR?
I should know it because I watched it fall asleep, but someone look it up really quick.
Audio,
but basically,
sound,
sensory.
Oh, it's like relaxing.
Yeah, audio, sensory.
So you're trying to say I put people to sleep, huh?
No. It's just it's calming and relaxing. Some people watch it fall asleep, but it's like if you want to if you want to almost meditate and not think about anything except just relax and put your mind that's one of these people watching.
Cool. Well, thank you. High praise.
Okay, cool. So where do you guys? Oh, so I was going to say. So I met with these administrators from Makerspace at Los Angeles Library. I believe they're from the LA area, and they were looking for ways that NVIDIA can be integrated in Makerspace. And one of the things I thought of right away was your stream here, Jen Eric, where I thought these kind of projects that you're doing are totally perfectly catered for Makerspace environment and teaching folks how to tackle a project like this with your hands and I thought Isaac Sim would be like a fantastic kind of like, I think it's pretty exciting for kids to actually fool around with robots. So anyway, so we may have a guest on this show soon if they decide to partake.
I hope so.
A lot of
That'd
fun.
be great. We could do a variety of it. This where we're headed right now with JetRacer, of training it in Omniverse and then deploying a real JetRacer car. That'd be great for Makerspace, wouldn't it?
Absolutely, it would be perfect. And I actually said, like, I'm sure a bunch of us could chip in and we can get them the kit, and the little gift
This
from
one?
us to get them started. Yeah, that's it. That's what you just bought.
Uh-huh.
Cool.
Nice.
I also bought a lot of peripherals too, so don't.
You came back. You came back with a big stoop of packages.
Well, it was just one package, and then in that one package there's multiple packages. So
Nice.
Yes.
Very cool. So he's asking what's in the kit. Oh, she's going to do an unboxing. Maybe we need to go.
Well, I can if we want. I got it open.
That's another great category of YouTube videos. You guys are covering all the bases here on this stream. The unboxing.
This is Eric's stream. I'm not gonna steal the show.
No. This is Eric and Jen's stream. This is Eric and.
All right. So First of all, we got some batteries. They're all in their nice little packages. I'll tell you that. They're huge. Look how huge these things are.
Those are big batteries.
I believe. Oh, and then this is where all the batteries sit. Right.
Okay.
So this is kind of like, I believe, the base, right? The base of the car. You're like, I don't know.
I think there were two JetRacers. There's the Tamiya.
Uh-huh.
And then there's another one that's the Latrax Rally.
Yeah,
and
we'll see which one it is.
Latrax Rally.
Yeah, and we'll see. And then we got wheels.
Now we're talking.
All right. And you know what's interesting is that they're shiny.
Yeah, they they look a little beefier than I envisioned.
Yeah, those look really nice.
Yes, your Starbucks for comparison.
It's like the size of the coffee that it looks like.
That's one Starbucks tall. Okay.
Yeah. One Starbucks tall. Obviously, some bubble wrap.
There we go.
Save that for
later.
Mm-hmm. Yeah. Bumper.
Nice.
Does that look like it will be like effective?
Probably.
We hope so.
I'd hope so. There's Oh my gosh, I feel like I'm getting old.
Well,
not entirely too sure what the wiring is on this bad boy, but there seems to be some chip and wire. It might be the Wi-Fi adapter.
Hopefully there's a nice diagram list so you know what's what.
Yeah. Ooh, wait, this is neat. I actually have to take this out of the bag to actually really show it. Hold on.
The multiplexer?
No.
Look at this green.
Cool.
Is it green? It's hard to tell from your camera, but is it green?
I know. It is green.
I'm gonna send you a nice camera. You deserve a good camera.
Well, okay. The thing is that I use my laptop when I'm at my dad's place. So I do have a nice camera at home.
How often are you back and forth?
Every Thursdays I'm at my dad's.
Okay, yeah, then we need to get you a good camera for Thursday. Thursday cam.
You don't like the backwash of this, or
it is very heavenly, but
so Zia said no batteries. No, there is batteries.
Yeah, that was the first thing she showed, Zia.
Batteries.
Come on.
You get 3.
I've heard,
Three
to
batteries.
be fair, it's kind of hard to see with some of the reflections on the packaging.
Yeah, it is very reflective packaging.
But like, if you think about it, this is like the safety packaging, so that way like nothing gets like electrostatic.
Oh, right.
and
I
doesn't
see.
ruin
Right. Yeah, that makes
any of the
sense.
components. So
That is fair.
that is important to note, that you are buying quality. You know.
See, I really like having Yuito around because he's just got compliments. Jen has nice. I
Nice glasses.
I like
Actually, it was funny. I was in a meeting with Dennis from the Replicator team, and we have the same glasses.
Those ones go dark outside or no?
Huh?
Do those go dark? Do they go dark outside?
Oh yeah. These are my outdoor ones, so they go dark. I need them for when I drive. Otherwise,
so
I'm gonna be.
Vince has a pair of those, and he has a very sunny yard. You can always tell when in the beginning of a meeting if Vince was just outside, because they take like 5 minutes to adjust. So he'll come into a meeting and they're like totally black. You can't see anything. Like, Vince, were you just outside?
Yeah. Oh, but it comes with a lot of screws and bolts. I'm pulling out. But the best part, here's the best part. This I was hoping for. Well, bam.
Oh, there we
Let me
go.
go to solo.
Gamepad style.
You get your own gamepad with it, and it looks like it looks very similar to a PlayStation controller. Minus,
definitely looks legit. Is that a screen on the top? No.
No,
Okay.
that's probably where the sensor is.
Yeah.
right?
Okay.
Oh,
Cool.
okay.
Does it feel like it's got a little weight to it?
No, this is actually like super light, minus whatever's jiggling it. Oh, USB.
Nice. Cool.
Very cool.
Let's see here. That's awesome. Let's see where. Oh yeah, there's JetRacer. Here we've got our scene. Let's see if we can start to figure out how to get this car driving using. Let's see. I'll go back to that repo. Just a second here. Just a second. Yeah, if we come back here, docs, examples. We've got this road following example. We're going to we'll try to do that here in Omniverse next. Okay. Let's see here. So we've got our scene, we've got our car. Let's go ahead and open up the Jupyter Notebook. I just installed an updated Isaac. That's why I have to install this notebook extension again. Cool. So I go to Window right there. All right, let's open up this notebook. See if this works. It's 127.0.0.1 port 8225 lab. Okay. See if it opens here. Cool. We've got a brand new Jupyter Notebook right here. Now I've also cloned the JetRacer, wrong page. I've cloned the JetRacer repository from GitHub. And if I go to notebooks, here's road following. Let's actually double check that I'm opening the right one. Right here. Oh, we want to open up the interactive regression notebook. I think this is where we actually train it. So interactive regression right here. And what we'll do, we'll pop open the Jupyter Lab. And I've got my files here. You can just drag and drop. Isn't that nice? And here we go. Here's our lab. And we'll just start. Let's just go through the code. Now, This is all designed to work on the JetRacer right now. And so it's not going to work. It's going to break. So for example, we've got okay. From jetcam.csi camera, import CSI camera. And then, so basically right here, oh, just a second here. Great question from Zia. A couple of good questions. So we are doing supervised learning. That's right. This Jupyter Notebook, basically what it does on the JetRacer is it will pull up an image of, I can pull up the webcam on the JetRacer, and you click on a point. So you put the car at a random spot, and then what it sees shows up on the camera, and you click as far down the track as you can of where it should be steering, where it should be going, and that's giving you these data points. And then, did the Jupyter Notebook Lab spawn on its own from loading the extension? The Jupyter Lab, I think turning on the extension starts the Jupyter server in the background, but then clicking on the Jupyter, you go to, if you go to Window, Embedded Jupyter Notebook, it pulls up this little pop-up that tells you the address of the Jupyter Notebook. You open up a web browser like this, and you just go ahead and type that address into your browser, and that will connect to the Jupyter Notebook. Great
That
question.
pop-up should just put it into your
Browser?
no, yeah, just like it should just be copy and paste.
Oh, like a clipboard
yeah.
kind of thing.
Well, I was going to
where-
say, you just open. I wonder if you could just pop open the browser tab with the address instead of that thing.
Oh, if we had like a web browser built inside Omniverse?
No, I think you can just open up an external process from Python, can't you? Couldn't you just like launch Internet Explorer or Edge
Yeah.
or Chrome or default browser?
Good, but I think you would have to allow for administrator permissions to do that. So that might get a little bit tricky. But it
Might get
really just
dicey.
depends, right? Like it would be something very similar to how you kind of did your Microsoft Office stuff, but like it might just be a security risk, which is probably why they chose not to do that.
Yeah, that's a good point. But even making it copy and paste would be
Yeah.
nice, right? Like
Yeah.
Edmar was saying. I wonder if you could just put it into the clipboard.
That would be.
Yeah.
I mean,
Be easy,
I've
right?
seen how to do that. It makes it very, very helpful.
All right. So what do we got here? Yeah, so let's take a look. There's this jetcam.csi camera. Oh, there we go. That's a great idea. Psh. Maybe just embed a clickable link in the dialog. I like it. I like it. If you can. I don't know if I can.
Who do we got to talk to?
Probably.
Damien?
Yeah, right? These are great. This is great feedback. So there must be this JetCam folder. Let's take a look at the repository. From jetcam.csi camera, import CSI camera. So let's take a look. They're here, these Python files. I'm looking for jetcam.csi camera. I don't know where that library is. Is that, let's see. Let's just try to find it, okay? Python jetcam.
Is it not part of the original zip that you had?
It's totally not. But if you look at it here, there's this jetcam library. So I wonder if it's just a Python import. Let's see what happens.
It hasn't ran yet. There you go.
No module named JetCam. Let's see. So we could see, but it's not going to help us anyway because we don't. The JetCam interface is on Jetson, and I think we want to replace this code right here with a block that just shows a camera from within Omniverse, right? So we're going to comment this out here. There we go. And let's duplicate the block. And let's see, let's grab this. And we want to grab, right now I'm counting camera 1. And if you look inside of JetRacer, the car, and then under the chassis, I put camera 1 right there. So let's move camera 1 into a little bit better spot, like closer to where it's going to be on the actual car. We can go to its properties even. We're using wide angle lenses. And so focus distance, focal length.
So out of curiosity, is there a
There you
reason
go.
why you decided to put the camera underneath the chassis?
Yeah. Change it to fisheye. Whoa. Yeah, this is more like what we're going to have.
Whoa.
I know,
Whoa.
right? That's a full sphere. So it's not quite that.
That's trippy.
That is trippy. That's what pigeons see. You just make a max field of view. Where is it?
That's true. You're saying that on Waymo, they have the camera way up high on the roof. I guess those are.
I'll just start it with it here. Okay. The reason I did that, if I go to my perspective camera, and if I make cameras visible, you can see our camera right here, little baby camera, looking forward. Oh, that's not where it's going to be at all. It's like way out front. It's more like here on the actual car. But then I think it's a wide angle, and I've got to figure that out. Do you know how to make it wide angle?
Yeah.
So now if we go to camera 1, yeah, there we go. Nice
wow.
wide angle lens, right? Cool. And the reason I put it under the chassis is so that when the car's driving around, the camera is stuck to it and moves with it. And so whatever rigid body, so the chassis is a rigid body, and it's essentially like it's bolted to the chassis.
Okay.
Anything you group with a rigid body just moves with it. If I had put the camera outside, we could I don't know, code some logic to make it follow or something. But I find this is the easiest way to set up a chase cam, and really that's the way the camera is on the car. Is it's just bolted to the chassis, right? Yeah.
So yours is going to be going on the chassis, whereas like the Jetson Racer one, it's connected to the chassis, but then it has this this weird pedestal where it sits on top of. Yeah.
Yeah, but it's still, that's all rigid. That's all rigidly attached. Yeah. And so if you look at this car, or if I zoom in here, here's the camera, and I've kind of put it where if we had modeled that bracket, that's about where it would sit, you know? Not exactly. It's actually maybe a little further back. and maybe just a little tilted down. It's not dead on,
Right.
but
So even if it has a bracket, it's still part of the chassis, so it would
yeah.
still
So
move with the chassis.
yeah, if we did a CAD model of that bracket, we just drag it under the chassis anyway, and just we give it a mesh and a mass, but the rigid body is defined in the chassis. Here we
Right?
have
Because
the rigid
otherwise
body.
it would have collision problems and it would just freak out, right?
Yeah, and just also if you any mesh that goes under a given rigid body, they're all it's like they're all bolted together. They don't move relative to each other. They move as one unit.
Mm.
And so that's the way I organize my assembly structures. If I'm going for a simulation, is anything that's rigidly attached, I put into one assembly in CAD, and then I put those into one rigid body. And if you look here at the chassis assembly, if you look at that one, where's my link? Here it is. It's a payload. It's a referenced payload, and the payload is the chassis subassembly that I brought down from CAD. And so all of those items it's like one subassembly that's everything that's bolted together, if you will.
Interesting.
And that way, if we wanted to add parts to the chassis assembly, like add brackets, add those risers, anything that's bolted on, we could just go into our Onshape. We could add those items. We could export that subassembly and then convert it to USD and then reattach it right here as a payload, and boom, it would all show up under that rigid body. We would have to go into the sub meshes and make sure they're mass properties, make sure they have a mesh and make sure they have good mass properties. But really it'd work pretty good. And then if you look at even the collision group, is that done by rigid body or by? No. And then we would have to make sure all those meshes were correctly added to this collision group. So that would fix the collisions. That'd be like the CAD to Omniverse pipeline. So yeah, there we go. So that's why the camera is where it is. That's why this is laid out the way it is. Let's check. Yeah, camera 1 is a nice looking wide angle lens now. And but what we want to do is we want to get this view, this camera view, showing up in our Jupyter Notebook. And then what we'll do is we go here and click, and that tells the car where I should steer to in this, if it had this view. And then we'll just and probably what I would do is just hook the Xbox controller up to this car, and then just drive it around, and pretty often just go to the Jupyter Notebook and do that click step. Click, click, click as we drive around the track. Where would you steer? And maybe even put it a little bit off angle sometimes on purpose, and so it teaches it to fix itself. But yeah, I think that's the overall workflow for the reinforced learning. Let's go through this notebook and see. It looks like, yeah, we get the camera. This hidden cell, it looks like it's initializing PyTorch, or it's not. No, he used not PyTorch. What's the other one? No, it is PyTorch or Torch Vision.
Yeah, it should be PyTorch, right?
Yeah, PyTorch. Cool. And then we're going to get this all working, and it looks like he just where is it? Manually update counts, create widgets, sets the active data set, update counts when you select a new category. That defines the function save snapshot. I'm not seeing where you actually click yet. Oh. More initializing the model. Here we go. Live execution. Patch size. Training it.
And is this notebook available for everybody to get as well?
Totally. Well, the one I've got right now is the original. It's available on the JetRacer GitHub repo. Let's go to that.
Because I can't tell if this is the different from the one that we've been using or if it's
The new one. Yeah, it's the second.
Yeah.
So let me walk everyone through that. That's a great question. So here we are at the JetRacer GitHub repo, and I'm going to copy that link, post that link for everyone in the chat. And if you go to this README file on the front page is really good. If you go down to examples, what we've done so far is this basic motion example. And that's a Jupyter Notebook that will turn the wheels and turn the throttle on. Just be careful because it turns the throttle on. So like I would lift your car off the ground before you do it. Otherwise your car is going to run off. I almost lost my car that way. I had it on the bookshelf. No. It was like it drove off, but it caught on the edge. I was like, oh shoot. So that's example 1. So example 2, okay, it pulls up this widget that you can use to just kind of like you go around and then you click where it should go. See how there he's like clicking? And then you can train it right there from this widget.
Very cool.
That's so cool. And so this widget Jen, you could use this notebook on your JetRacer once you have it assembled. And just by hand train your JetRacer to drive around a track without any kind of without using Isaac Sim, really. Just do it in real life. But we want to do it in Isaac Sim.
Yes.
So we're taking this one that lets you teach it to do road following in real life, and we're doing it on Isaac Sim instead. And in theory, like if we had similar, he has green cones here, but if we use similar assets or to whatever we're doing in real life, we should be able to train it.
Yeah, I wonder
to real life.
I wonder if you can get your kids to get them some chalk and then see if they can draw a track for you.
Totally.
On the ground and be like, go wild with it, and then see how the robot goes.
Well, we could do that in real life for sure. I don't see how that works, or it could just be a line. It doesn't even have to be both sides. I think you could just draw a line and have it follow the line, and I think they would love it. I should do that. I think they would love it.
Yeah.
And but the other question is, could we do that in Omniverse? And I don't know. And then, there's all kinds of questions I have about that. Like, what if we just did lines in Omniverse and did random ones and train it on a whole bunch of different random lines? Could my kids just draw a line on the road, and would it work? And I think it probably would, which would be cool. All righty. So let's do this. And the way I approached this before, where are you? I opened the new tab. Is I just went through each block and just fixed it block by block. So we have 8 minutes left. Oh, here we go. Great question. How well does a robot trained in Omniverse translate over to real life? We haven't done it yet ourselves. I have seen videos of people who have done it successfully. And our goal here is to figure this out and make it really easy to go back and forth between sim and real. I have crossed that sim to real gap with defect detection. I did some scratches on a car panel, and I learned a lot. And makes me very optimistic. And the reason is because what I learned, the really intimidating thing for me when I did that first project was like, how am I going to make this scene so realistic that the AI can't tell between the sim and the real? And that was really an intimidating prospect. But what I learned in that project is it doesn't, the digital scene, the sim scene doesn't have to be perfectly accurate. It just, in fact, it can be maybe more of a caricature that that makes all of the problems an AI might have in the real world a little bit bigger and harder. So like if your AI has problems with reflections, make your sim scene even more reflective. And so it doesn't have to be exactly the same as real life. It can be kind of magnify those problems. And that I think will give you an even more robust a robust model trained from sim than you would get if you just did it in real life. So you can kind of, I think there's some artistry here. There's some artistry to this of like it's not making the scene exactly accurate and the physics exactly accurate. It's making them making it so that they teach. They're like drills. There we go. It's like if you want to be a fast swimmer, you do drills, right? And a drill is not exactly how you swim to go fast. It's more of an exaggeration. It exaggerates things to teach you. And our goal is to teach the AI. And so we're kind of coming up with drills in Isaac Sim to teach our robots well. There we go. And I think, and once you have that paradigm shift in mind, it's like, okay, it doesn't have to be perfect or exactly the same. It just has to maybe exaggerate the problems I might run into. And that's actually a lot easier, I'd say. There we go. Great question. So the next question is, how do we display a camera in this widget, right? And that is a good question. So I don't think we've got 4 minutes. I don't think it's going to be enough time to do that. So I think we'll just wrap up for today. But that's the next step is when this widget gets created. Let me just delete this block. We want to replace this code with code that does the same thing in Omniverse. And we'll display, so we want to get a handle on that camera and display the image right in the window. And I'm wondering, oh, here we go. CSI camera. Import CSI camera. Import USB camera. Okay. So camera is a CSI camera, but then how do we display it, right? Let's find out real quick. I'm just curious because we might be able to, let's see. All right. Lots of cameras. Unobserve all callbacks from camera in case we are running the cell for a second time. Camera.height. Clickable image widget. And a snapshot widget. We got some work to do, don't we?
Yeah.
This is going to be a little bit harder than the basic motion one, but no surprise there. We'll just take it one step at a time. Or I'll work on a few steps during the week and catch you all up. Let's see. Clickable image widget. Jupyter. This is cool. Dataset widget, category widget. So we're going to take this width. This is the width and the height, right? I'm just not sure where. Okay, traitlets.dlink. The camera widget value. Okay. So I don't know what this D-link. Are you familiar with traitlets, Jen?
Is that like a dialogue link? I would assume it's trying to communicate using IoT stuff. Is what I would assume.
Where's the IoT stuff? Oh, I commented that out a bunch of times.
Because I think what that is doing is it's creating a connection between the Jupyter Notebook and the camera. And then in the comment, it says it's creating the image preview. So I would assume it's probably previewing whatever the camera's seeing at that time.
Oh, yeah.
But I could be completely wrong. I'm just going off of what I'm looking at.
How do I... I'm terrible with Jupyter. Okay, I made this a header. Now how do I just edit mode?
Run it.
Oh, okay.
There you go. Yeah.
All right. Yeah, okay. So we've got the CSI camera, and then we're creating a clickable image widget. And then we're linking the camera to the camera widget. Oh, here we go. BGR8 to JPEG is a transform.
Blue, green, red. Oh, okay. So this is not using RGB. This is using BGR for anybody that can't tell the difference.
But I think we might need to dig in. If we look at traitlist.dlink, it's not it. It's interesting. That's not really a.
So what did it just say? Just D-Link, or what was the code line again?
The function is running as traitlist.dlink.
Okay. So if you just go to the base documentation, I think it's and then if you search for D-Link there. Thing. Links. Oh, it's probably it might be a directional link. That makes sense, right? Because if we're giving are we giving it a transform? What are the parameters?
It is. It's the transform is the BGR8 to JPEG.
Okay, so so it's a directional link then.
Right. Data transfer source and target. Cool. And so we just need to what is this? The source is what?
The source is
the camera, right?
Yeah.
And which is a what?
CSI camera.
CSI camera. Let's say jetcam.csi camera. Let's take a look at that. JetCam, CSI camera, capture device, frames per second, width, height. Oh, here we go. Read, right? So basically, I'm guessing that it's just calling that read function, which returns an image. So we just need a class like CSI camera that has a read function that returns the image from the camera. Does that sound about right?
Yeah, and I think there's already functionality where you can actually grab in Omniverse, where you can actually get the camera and then you can get the images from the camera. Like you can capture an image from the camera.
Yeah. Just taking a look. Where
But
are
you
we?
should also, one thing to note, and this sometimes stumps people,
Uh-huh.
is if you're using any type of cameras or image readers, the main convention is actually BGR, which is blue, green, red. But there is some cases where some functionalities use RGB, which is red, green, blue. So it changes the order a bit. So if you're wondering why your colors might be funky, you just need to swap the red and the blue. And
So
that should usually fix things.
there's probably a good chance here that we've got this transform BGR8 to JPEG. And so when we first hook this up, we might get really weird colors.
You might,
And
depending
then maybe there's
on
another
what
transform.
functionalities. Yeah.
Let's see. I don't know that what transforms are available, but maybe there's just an RGB8, huh? I'll probably just give that a crack. Oh, Wayne, we're 5 minutes over.
What the?
Where'd that time go? So we're gonna keep having fun next week. And
Yeah.
I'm really excited to get this going. I think I'm pretty optimistic that it's going to work for us. And we'll be able to train robots using supervised learning in Isaac Sim. And we'll publish it. Yeah. So until next week, have a good one. And hop on to Discord. I'd love to hear what you all are doing with your robotics projects.
What channel do you want them to go to on Discord?
The JetRacer channel, for sure.
Of course. Okay, cool.
Oh, absolutely.
And then next week, anyone using Real Illusion on our Wednesday live stream, we're going to have Real Illusion's VP, John Martin. We're going to talk about their connector updates and live sync. So really cool. A lot of people using Real Illusion for characters. And anyway, John's great to have on. He's going to show his workflow. So it'll be a lot of fun.
Cool. Thank you.
All right. Until then.
Happy roboting? We need like some kind of a tag phrase or something.
Nah, you just say bye.
Okay.
Just cut them
Jen
off.
says bye.
Bye, everybody.
All right. Catch y'all later.